in this lecture. Generally, the parameter passing methods are of four types. One, call by value, where the actual parameters are evaluated and copied into dummy or formal parameters before the function call is made. Thus, there is a separate copies for the formals and actuals, and so there is no side effect of that function call. Second method is call by reference, where the address of the actual parameters are passed to the formals rather than their values. So the formal and the actual parameters, they share the same copy or same location in the memory, and this will lead to the side effect. We will talk about that later. Call by copy restore, which is also called as call by value or result, or copy in or copy out. This is a combination of the first two methods, call by value and call by reference. What it does, at the time of function call, it uses call by value method, and on the return it uses call by reference method. So where the formals are copied again back to the actuals. Call by name is a method which also called as macro expansion or inline expansion. What is the basic principle? The entire function body is substituted. So every formal parameter is substituted by the actual. However, a separate copy is maintained for those local variables in the called function having same name as the actual parameters. We will see these all these methods and their difference with simple examples. So let's look at call by value. Here is a program. Mind you, even though it looks like a C program, I am not writing all the details. So sometimes on some slides, it may not follow the exact C syntax. So it is generally it is written, and since all of you are familiar with C, I am making use of that. What you can see in this program, there is a main function and there is a function called as func. And the main program calls the function func with two actual parameters g and b. This g and b, out of this, g is a global variable, whereas b is local to main. And on the right hand side you can see there are boxes shown. These are nothing but the memory location given for the variables. For example, this is a memory location for G and this is a memory location for B. Inside the box we'll go on writing the values. So what happens when the function call is made? Since the method is called by value, the actuals are first evaluated and copied to dummy. Now G and B are actuals, while P and Q are dummy parameters. So value of G will be copied to P, right? So 2 will be copied to P, and value of B, which is initially 3, that will be copied to Q. And now you can very well look at these three statements. The first statement will make this value as 4. The next statement is interesting. It is assigning a value to G. Mind you, G is not local, it is global. So P value is now already become 4 plus Q value of 3, it becomes 7, and that's why 7 gets written in this memory location. And lastly, the correct value of Q is 3. So 3 plus 5 is 8. So this 8 value is copied here. Now the function returns back. Since the actual and the formal, they have a separate copies. When you try to print the value of G, what you can see in the box for G? 7. And what you can see in the box for B? 3. That's why the output of the program will be 7 and 3. You already know about this. Why I'm explaining this? Because as we go for further methods, this will be useful. Now let's look at call by reference. Call by reference, as I already said, the address of the actuals will be given to the formals. Look, we don't write in C in this fashion, we attach a star. I already said I'm not interested in the language or the syntax. We are just understanding the concept. In other words, the actual and the formal parameters are tightly interlocked with each other because they share the same location. Now, what is this 100? You can see this is the name just for our convenience. This is a memory location whose address is 100, and this is a memory location designated as B whose address is 200. So in call by reference, we don't copy the value, but we copy the address. So the value of P is 100 and value of Q is 200. Now what happens? The first statement when the function call is made, P will become 4. So initially it was 2, right? Now this will become 4. Why I'm writing 4 in box for G? Because G is equivalent now to P. G is tightly interlocked with P and B is interlocked with Q. The next statement where the current value of P, which is 4, and the current value of Q, which is B, is 3, that is copied, and so you get the value to be 4. And last statement Q, that will modify the value of Q to be 3 plus 5, that becomes 8. And so now when you try to print the value of G, G is what is shown in the box for G, 7. And what is shown in box for B, 8. Output of the program will be 7 and 8. Right? Now we are going for a very interesting kind of parameter passing method which is called as call by copy restore. Now it is a combination, that's why you can see the arrows are bidirectional. At the time of function call, it behaves like call by value. So the initial value of G, which is 2, gets copied into P. And when the function is over, whatever will be the final value of P, that will be copied back into the actual parameter G. Same thing will be done for B. Now the function, you can very well understand what is the final value of P, 4. So 4 is getting copied even though G was in between have a value of 7. At the end of the function, the value of P is 4, that is copied, and value of Q, final value is 8, that gets copied. So when you try to print the values of G and B, you will get now 4 and 8. I hope you understood copy restore or value result, or it is called as copy in, copy out. When you do copy in, at the time of function call. When you do copy out, at the time of function exit or function return. And the last one is now is call by name. Now call by name is actually, you all must have used hash define in C program, which is nothing but a macro. And what is the idea? Here you can see the call to the function GB. This entire function call is replaced by the body of the function. So what I've done for your understanding, I written it as it is. Can you see now? This func is replaced by these 3 statements. And moreover, wherever the variable P has occurred, it has been replaced by G. And wherever variable Q has occurred, it has been replaced by B. And so now if you try to print the value of GDB here, what is going to happen is self-explanatory. Call by name will produce 7 and 8. So that's the difference. Although we are not really interested in what will be the output, we are interested in the internal mechanism. I hope you have understood how internally all these things works. Now let's take a very interesting example. And this example is on this side, right? So initially the global x has a value of 1. Now when you make a call to the function 1, what's going to happen? If you are using call by value, the current value of 1 will be copied in p. Now p becomes 2. But then x is not local, it is global. So it is assigned a value of 0. So when you try to print the value of x, how much it will be? It will be 0. So output of the program, if you are using call by value is 0. Similarly, you can understand for call by reference and call by name. But very interestingly, look at what is the output of call by value result. It will be 2 and it will not be 0 as in other cases. Why it will be 2? So if you try to understand, when you make a call, initial value is 1. So p value is 1. Now p value is 2 and x value is 0. That is okay. But when the function is over, since you are using value result method, which is also called as copy in or copy out, what's going to happen? What is the current value of p? 2. That 2 will be copied in the actual x. And so when you try to print x, it will be 2. So like this, you can try so many examples on your own. And this must have given you a good idea of what is the difference between this. Coming to the comparison of these four methods, which method is efficient? So we call it as speed. Call by value is fast. Call by reference is slowest because it involves indirect referencing, pointers. Call by value result will be intermediate and call by name will be fastest because it is a macro substitution. Side effects, in call by value there is no side effect, but in all other methods there will be a side effect. And most of the languages they support both call by value and call by reference. But for very old language like Fortran that supports call by value result method, and a language Algol has got a provision for call by name. So in this lecture, students, what we have studied is the four different parameter passing methods, and you should be aware of these methods and their differences. You try to understand the mechanism and not the actual output, because we are interested in the output as such. So in the next class, we'll deal with the next topic. Thank you.